Okay. So the first one, it says graph in slope-intercept form. This is your slope-intercept form, y equals mx plus b, where m is our slope. It is the number in front of x, not mx. It's just the m, the coefficient to the x. And then your b is your y-intercept. And that is an ordered pair. That is 0 and then b, whatever the constant is your y-intercept. Okay? The first step would be to solve for y. If it's not already solved, you want it to say y equals. Then you're going to write down or list your m and your b. So find your slope and your y-intercept. So m equals b equals, just like what you see here. The third step will be to plot the y-intercept. I mean, literally graph it. And if it's a y-intercept, guys, it should be on the y-axis, right? Like that's the definition. And then the last thing is to, from the y-intercept, so from the y-intercept, you're going to count rise over run. Okay? One thing to note on your slope, if it is positive, it should slant up. Okay, so if my slope is positive, we talked about this yesterday, a positive slope should slant up, a negative slope should slant down. And make sure you're doing rise over run. Then you can plug it into your calculator and confirm that you did it correctly. Okay? Alright, so for this first example, it is y equals negative 2/3 x minus 1. Again, my slope is the number in front of the x, not the x itself. So it's negative 2/3, so it's going to slant down. I like to kind of just sketch that downward slant, and it just helps me remember that whenever I actually graph it. And the y-intercept is your constant. So the y-intercept is -1, or the coordinate 0, -1. It is a point. So we start by plotting. See if I can zoom in just a little bit. We start by plotting that y-intercept first. So go to the y-axis. This is your y-axis, and go to -1. From -1, you are going to count rise over run. So we're going to count 2/3. It is negative, so it should go, if you go up 2, you're going to go 1, 2, 3 to the left. Or go down 2, 1, 2, 3 to the right. 1, 2, 1, 2, 3. You can use the side of your ID to make it a straight line. And then it should have arrows at both ends. Okay? All right, next one. The next one says 2x, and then there's nothing after it. That means that technically there's a +0 after it, but it does have an x. So this is my m. So my m is 2, +2, or 2/1. It's going to slant up. And then my b, my y-intercept, is 0, or the origin, 0, 0. Start by plotting 0, 0, and we have a +2/1 slope. So again, up 2 to the right 1, up 2 to the right 1, or down 2 and to the left 1. It should be a fairly steep line, slanted up, or rising. Okay. Example 2. It says y equals 5x plus 42. I believe it's talking about length and stuff, but I want to read the context because this is probably one that on your assignment will be like a word problem. Page 91. Okay, yeah, it says the body length y in inches of a walrus calf can be modeled by y equals 5x plus 42, where x is the calf's age in months. So this is the age, and then the whole thing gives you the length. So the whole thing, it says, is the length. Okay? And then they want us to identify the slope. So just as we were doing, the slope is still 5x, or 5. It's a positive, so it should be going up. So 5 over 1, or 5. The y-intercept is 42, which means it starts at 42 inches. It's 42 inches long at birth. So at year 0 or month 0, it is already 42 inches long. Okay? And then they want us to graph that. So we have to do the scale down here. This is your x, this is your age in months, this is your length in inches. So if it starts at 42, we don't really want to start 0 and do 1, 2, 3, right? We're not going to make it. So let's, we can count by tens, or every other one you can label 20 is what I did. Every other one I labeled 20, and so technically it's counting by tens. You want it to make sure that you can see the start, and then, you know, see a good portion of the line. All right, so it starts at 42, right? So somewhere over here, right above the 40. If this is 50, then it's going to be literally right above the 40. That's 42. And then it's going up 5 each time. Again, not going to be super accurate, but going up 5 each time. If you wanted to count by 5s, but I just don't think we would get there. We'd have to do the little thing where it like cuts it. So this is 42. So plus 5 would be what? Let's do
47.
Yeah, let me label this. I forgot to label my X. I'm sorry. 8, 9. Age in months. I probably should have counted by something different, huh? It's okay. And then you may want to, we can even set up our little table. And again, you have the calculators. You could always type that in. Might be the quickest way. Let me get that up. So what did we say it was? 5x plus 42. So yeah, 1 is going to be 47. What's 2 going to be? 52. 3, 57. 62. I'm just adding 5 each time. And then I'm going to just kind of skip to 10. How much that's going to be? Will be 5 times, it'd be 5 times 10, which is 50, plus 42. Almost wrote 42. 92. So again, we can just estimate like where those would be. And you don't have to plot every single one. Just get a good number on there. So at 2, it was 52, which is somewhere around here. Because we can go up 10 every 2 months. Would be maybe a little bit easier to graph. 10, we are at 92. Like that. All right, so what do we have? What do we know about domain and range? Yep. Domain is your X, range is your Y. So domain, this is talking about months, age in months, right? And the range is your Y, so it's talking about the length in inches. Okay? So what would you give for the domain and range of this function, though? Let's start with the range. Where did it start? What Y value did he start at? 42. And so we can safely say that it's going to be greater than or equal to 42. And then the domain, he started at age 0, right? So at birth, which would be age 0. Technically, there would be a limit if you're really talking about it, but it's okay. All right. Everybody good? All right, moving on. Now we're graphing in standard form. Who can remember what standard form?
Isn't it like a y and x on the side?
Yes, yes. It is this right here. It is ax plus by equals c. That is standard form. To get the x-intercept would be a number, comma, 0, right? The x value would be a number, and then the y value would be a 0. So you're going to plug in 0 for the y and then solve. To get the y-intercept, guess what we're going to do? It's when the x is 0, so we're going to plug a 0 in for x and solve. Okay? So looking at this first one, to get the x-intercept, if I plug a 0 in right there, I like to just kind of put my pen over it and then just solve it that way. Because if I put a 0 in for y, that y goes away, right? I don't have it anymore. And that whole thing in the middle right there zeroes out. So I personally like to cover it up. I see it better on like what I need to do next. So for my x-intercept, it would just be 9x equals 36. Like you're literally getting rid of the y. It zeroes out. And then just continue to solve it. So then I would divide by 9 and get x equals 4. So the x-intercept, which needs to be written as an ordered pair, would be 4, comma 0. We always write intercepts as ordered pairs. Okay? And then the y-intercept, same thing, except you're going to put your pen or finger or something over the x. Literally, the x goes away. Okay? He's not there. So then if I do that, I get negative 4y equals 36. Divide by negative 4. So what is the y-intercept? Negative 9, or the point 0, negative 9. Again, intercepts always need to have a final answer written as an ordered pair, okay, with parentheses. Then we can plot those two. So I can do 4, 0, 1, 2, 3, 4, 0 right here. And then negative 9, 0, which is down here. We can count by twos if y'all want. 2, 4, 6, 8. Way down there. We're just going to say we counted by twos. And it goes up like that. Okay? All right, same thing. It says find the x and y intercepts. Again, for the x-intercept, omit the y. So I'm going to write down 5x equals 10. And then solve it. Divide by 5. And so I get x equals 2. So my x-intercept is the ordered pair 2, 0, which is right here. And label it on your graph. Make sure on the right axis, the x-axis, at positive 2, 0. Then the y-intercept. Again, for the y-intercept, we omit the x. So that would be 2y equals 10. And so y equals 5. And it's the ordered pair 0, 5. Again, it should be on the y-axis now at positive 5. 1, 2, 3, 4. Positive 5. And then just connect the two. Make sure you write them as ordered pairs, and then make sure you label them on your graph. All right, example 5, special cases. This is your horizontal verticals, right? This is your hoi vux. Okay? So, again, hoi vux is the acronym we use for that. If it's a y equals, if it doesn't have an x, so this one does not have an x in the entire equation, that means it is a hoi. The acronym does not have an x. So it's a hoi. And remember, hoi, I got it. Hoi stands for horizontal, 0 slope, so it's telling you the slope. And then the y says it has a y-intercept, and it's equal to, there's no x, it's equal to that. And so all the y values are 2, is what this says, okay? So you can tell everything about that line. So it's a horizontal, it's going to be a flat line. It's going to have a 0 slope, and it's going to cross the point 0, 2. It's going to have a y-intercept at 2. Every single y value is going to be positive 2. So we literally just draw a flat line at where y is equal to 2. Again, every single, if you were to look at a table for this one, every single y value would be 2. The x's would change, but every single y value would be 2. Okay, is what that says. Okay, there's no slope, so technically it's 0x, which is why we don't have it. All right, the opposite goes for when it's x equals. That is a vux. That is your vertical line. It stands for vertical, has an undefined slope, and it's an x equals. There's no y. So it's just x equals, and so the x value is negative 3. The y value is 0. It's going to cross the x-axis at negative 3. And it is a vertical line. People mix these up all the time. Okay? It is vertical. That is your undefined. That's not a function, right? That's the one that your calculator will not graph. So if you forget, type it in. You're not going to be able to type x equals, but type in the y equals. It'll show you it's a flat line. All right, looking at our homework assignment. Here's my homework packet. And then, again, I like to write on the homework packet like what example to refer back to. So I'm going to try to do that for these as well. It is 2.3, so make sure you label your paper. And now, let me show y'all real quick. If you want to use my graphing paper, you can, for the ones you have to graph. In this drawer right here, I usually keep graphing paper. And I have 2 different kinds. If you want to, like a 6 per page, front and back, so this would be 12 total. If you didn't need like a lot of room to maybe solve an equation, just make sure you put the problem number next to it, okay? And then, or this one, like if you need to solve something, then you can use this one, which has 3 on each side. And I don't care if you want to use this or if you want to use your own regular graphing paper, okay? If you're drawing your own graphs, they need to be accurate, so just know that. But it stays in this drawer. Don't get up right now and get it. You can get it in just a minute. Let's talk about these problems real quick. But you are welcome to it at any time. It's in that second drawer. But just give me a minute. The first 4, 12, 14, 16, 18, it says graph the equation. That's just like example 1, right? I believe it was example 1. Let me make sure I have the right problem numbers. Yeah. So this is like example 1. You need to identify the slope, you need to identify the y-intercept, and you need to graph it, just like we did on example 1. Okay? 24 through 28 says find the x and y intercepts of the line. That's like the ones that we did on that second page. So example 3. Make sure you write them as ordered pairs. Okay? Tell me if it's an x or y intercept, and then write them as an ordered pair. 34 through 38 says graph the equation and label any intercepts. That's also example 3, but it's more like example 4. But either one. Intercepts, again, need to be written as ordered pairs, and then you're graphing these. Okay? So make sure you're graphing the ones that say graph. So far we have 4, 5, 6, 7 to graph. And then 60, that goes with the one we did on the front. This is like example 2 with the word problem. So it gives you the equation right here. It says that x is the number of nights. And it says that y is your cost. So your cost in dollars. Remember, word problems, we always want to make sure that we label our answer, okay? So your final answer, it says, where x is number of nights, graph the equation. So you're going to graph it just like we did, okay? So there's 8 graphs so far. And it says, what do the slope and y-intercept represent? Okay? Make sure slope is always a rate of change. That should have units on it, okay? So cost per night would be, and then your y-intercept would be like the original cost. All right. Oh, and 62. Sorry, I missed one. 62 is on the next page. This is also the word problem, so it's like example 2 as well. It also wants you to graph, and it gives you the equation right here. It says you purchase a 300-minute phone card. The function models the M, the number of minutes that remain on the card after W weeks. So the X is your W. The X is in the middle of the equation, so that's your W, which are your weeks. Okay? And then the M is your Y. Oops, sorry, I meant to put Y as the M. And that is the minutes, number of minutes. How many minutes per week do you use the card? So that kind of helps you out. Minutes per week should be your answer. Make sure you use your, give a reasonable domain and range, but you don't have to describe it really. Just graph it and give a reasonable domain and range. Bless you.